OK. So I hope you love stories as much as I do. And in fact, scary stories in production, no less. So let's go. Before that, of course, we're talking about my company. We do T-shirt too, like many. So I work for Neox. It's a consortium, several companies. A lot of companies are software developers. We host everything ourselves. So many Postgres databases, ranging, I think, several thousands. Some are pretty big, some are little databases, but we have a lot. We mainly work in healthcare, so data are important. Data are personal data. So, of course, we take security seriously. Myself, I'm the head of infrastructure. I began to work with Postgres 12 years ago now. Today I am manager, but I still try to keep a strong technical proficiency. And I love Postgres. And sometimes, not every day, but sometimes I'm called to help some partners or customers that have a pretty serious incident in production. And thanks to them, I can do this presentation. So thank you. And you'll see. So when you are called in another infrastructure that is not your own, you need to be very methodical, especially when there is a big problem. So every time I try to apply this. First, problem identification. Most of the time, you'll see the first sentence you hear to have the problem, the description of the problem, is not very clear. So you have to find out this and do some digging and find what is the problem exactly. For that, you need the environment. It's not your own, so you need to look around, see how it works. Do a diagnostic, of course. Find a solution. That's why we're here. And here I will give to you the takeaways, because when we see problems, that's when we can learn from them. That's what's important. OK. Before we begin, we are going to steal one directive from Robocop. We will not serve the public trust, nor uphold the law, but we will protect the innocent, so I will not do any name dropping. All my cases will remain anonymous. OK. So, first story. So that's the only sentence I got for this case. So my customers are not always sorted the same way. Why is that? There was some spoiler this morning about this case, but let's go. First thing, we need to know the environment. So it's a classical environment with an application, a primary, a replica. If you remember, we had we had Dev and Dirk that did something about that. So that's the same. And between them, it's a physical application. So the read operations are balanced between the primary and the replica. Sometimes they use the primary, sometimes they use the replica. It depends on the application code, actually. So what do we see? It was a strange problem. Sometimes the application did return some result, something is set some way, and sometimes in another way. So we tried to do the sort directly in the database. On the primary, of course, this is a reenactment because this is confidential information, but you see, we do sort. And then on the replica. Notice some difference? Something is not right? Or is it possible? Sorting is not the same. Shh. OK, so we need to know a little more. How can it be? So let's look at the operating system and how it works. It was, before the issue, it was like this. 2 Debian, same version, same Postgres version. Like I told you before, it was a physical replication. Everything was working. Then, the problem is the company decided to change it, but the wrong way. You'll see. This way. So actually, the decision was to use a FreeBSD, which is fine. FreeBSD is fine for all Postgres cluster. But to do that, they just began by the primary. and so what do we have? We have people that don't read the PostgreSQL documentation, basically. Because we know, you should know that you must have the same OS when you are doing physical replication. So why exactly? Because the collection is different. And in this case, it was even more different. It was UTF-8 on the Linux and C and FreeBSD. So for those who don't know, but we can talk about collection this morning a little bit. Collection are the set of rules that determine how text strings are sorted. So this is critical mismatch because it will lead to index corruption. In fact, since the data is sorted differently, you can insert duplicate data, for instance. So, yeah, pretty bad. How did we solve this? Any idea? Yeah, that's a bit of this. You have to move the cluster back to the same OS. You have to select one. And you have to reindex every index that has a collection. And then, of course, since it did work, I think, for 1 day in production, you will have some issues because some data will be duplicated because of the index corruption. So at this time, it's you need someone that has knowledge about the application that can correct those data. And it can take some time. So what did we learn from this? OK, it's in the documentation, but same OS for physical replication. And but there is something new that will come. In PG17, you have a new collection, that's CUTF-8. And it's very interesting because it's not tied to the OS, not tied to glibc. It's directly in Postgres. And if you want to know more, I cannot stress enough. You look at this conference that has taken place in Vancouver this summer. And you will see how to use this collection. It's even more, it's even faster than the classic UTF-8 collection. But it's only PG17. OK. Next case. Again, great description. From time to time, the application is slow. OK, this can be basically anything. First time you have a customer that tells you that, you just say, check your internet connection, should be it, and don't bother me. And this time it was a real issue. It was some time, but not all time. It was not very clear. So what do we see? At this customer, monitoring was not very good, monitoring tools. So we just, in the end, I just got to the server and run hashtop. And I saw this. Yeah, I think even there is more. So, but a little problem. The load is a little high, but it's something is wrong. Let's look at the process. OK. Everything in startup. Oh, there is another vacuum. At least something is working. There is a lot of them. So the server is not doing any work, by the way. At this point, it's just a starting connection, and that's all. The first thing you think when you see that is there is no puller. Maybe something is just opening and closing connection, and whatever. But it was not the case. There was a puller. The puller was a JDBC, but if you misconfigure a puller, you actually have the same, it works the same way as if you don't have any puller, because you can just pull until some point, then you will try to open more connection, and it will open, then close, because you are outside the puller. And this is what happens. Every hour, the application was, of course, most of the time the application that is the culprit. The application was running a task, which was opening many connections, and it was just crashing the whole production. So, what do we do? Fix the application. Easy. Yeah, right. It's not always possible. As DBA, you should know. So we have to work around this. Configure the puller correctly is very important. That's it. And also, I didn't see this in many shops, but having a connection churn monitoring to see the rate at which your connection is created and destroyed is important. It can help you catch this. And lower the max connections. Because if you work with developers, I have nothing against developers, but they will just say that they want more connection. More connection, more connection. Yeah, I need more connection. But they don't realize that every active connection will use a thread. So if you open like 1,000 connection, I don't think you have a server with 1,000 threads that can work with this. So, third case. The server is overloaded. This was an operator, so I did trust what he said a little more than a customer. But still, there was some monitoring in this case. So we have graphs. Nice, all right? This is a graph when everything is working. Everything is fine. The load is fine, so. And this is Monday morning, then the next week. Again, notice some difference. There's a little red, but maybe it's just here for colors. Nice, right? No. And the connection? The blue are active queries. So it's not normal. You should not have so many active queries at the same time. I think right there, it's just they restarted the application to see if it would fix the issue. Did not. So, investigation. This was kind of hard to catch. I did arrive a little after they began the investigation, actually. So we tried a lot of things. pgbadger, and when you set pgbadger with a duration statement to 0, you know something is wrong, because you're going to have a lot of logs to analyze, and it can take a lot of time. When you have more than 1 hour to just run pgbadger, that's bad. Then explain analyze of the queries, vacuum, analyze for table, bloat estimation, like we saw this morning, it's not easy to have a correct bloat estimation. We actually caught a lot of things here, but that was completely irrelevant to the issue. But we tried a lot of things, and it didn't solve anything. The database was always overloaded. So it was live production, already big customer. So at this time, you begin to want to fix the thing anyway, even if you don't know what is why it doesn't work. It feels a little like this in this case, where you are fixing a plane while it's in a war. So emergency fixes. I am not very proud of this, but desperate time, right? So we killed some statement every 2 minutes to prevent this. And we began to create a test cluster to replicate it. Oh, that's good, but most of the time, when you are in this situation, you need to take a step back and see the bigger picture. Because something doesn't change overnight. Or maybe. We were Monday morning, and maybe something happened the night before. But we didn't know at the time. But I had my suspicions. And of course, there was something. So in fact, it was just a minor PostgreSQL upgrade. But it did use a new system to deploy the configuration. Interesting, no? So I did look at the configuration itself, like every settings, but it was pretty quick because I saw this. So the value before was 32 gigabytes, by the way. So turns out if you divide your shared buffer by a factor of more than 4,000, some things don't work as well. This is 32 gigabytes. And can you find the 8 megabyte here? It's here. Yeah, it's right there. So, yeah, that's a big factor, you know? I think it's not even... yeah, I think 8 megabyte is even... it should never be... Even the dot is too big. So, yeah. So how to avoid this? Okay, of course, better deployment process. And the second one I love because the teams didn't talk between them. So the team changed things, doesn't say to the production team that it changed. That's why. But monitoring your PostgreSQL configuration value is something that is a good idea also. Most of the time you have monitoring of performance, CPU, disk I/O, everything. But configuration is not often, I didn't see more often the configuration in a monitoring system. And it can be a good idea. And by the way, it was incredible that the production still worked thanks to to Linux cache. File system cache did make it work. And this is actually pretty amazing because with 8 megabytes of shared buffer, I would think that nothing would work. But it did. OK, then. Too many simultaneous active connection. And this is very accurate because it's a monitoring system that says this. So, a little background on this. We have big servers. we talked about a server with many threads. This is one of those, a big beast with lots of CPU, lots of RAM, lots of disk, but also lots of databases. Around 600 databases per cluster. That's a lot. Every database is linked to one application and one application to one customer. OK, that's a lot, but it did work fine until still, you see some blue. Too many active queries. It looks like the other case, but it's not the same. And it happened one time and doesn't let go. still keeps all those queries active. But what are those queries this time? OK, who knows what is a subtrans? Yeah, subtransaction. OK, so when there is, again, a lot of them. I did truncate it because there was thousands of them. But, yeah, PG activity. When you have a PG activity, PG stat activity like this, again, nothing is working. It's completely stuck. You have substance. And if you don't know what it is, I think the first thing you look at is what is a substance. And it's actually, yes, it's a subtransaction. So a subtransaction is a transaction that can be started from another transaction. It's created by save point and exception. And even more fun, you can start a subtransaction from a subtransaction. And so on. You can have several transactions that are built one on the other. I thought that save point and exception are two keywords that we should play with Pavlo and Wordle. That's a fine one. And what's interesting in subtransaction is that it uses its own cache, a SLRU cache, a specific control lock that is different from the other transaction. And of course, we have a documentation about them. But here, the problem was there was too many subtransactions. And when there is too many subtransactions, we have subtransaction cache overflow. And because of this, the cache has a fixed size, and you cannot change it until at least in the current stable version of PostgreSQL. And we'll see why I'm saying stable right now, later. So, since we have cache overflow and we cannot change the cache size, how can we fix this? There is basically only two fixes possible. Again, fix your application so it doesn't use so many subtransactions. Or you have to reduce the number of databases per cluster. So basically you will cut your cluster in two, and you will have half the database on one cluster, half on the other, and you will double the cache, the subtransaction cache. So currently, that's the only way to fix that. And it's very difficult to catch because everything is working fine until one day this happened. So it's very important to be aware of subtransaction because it can catch you by surprise, and it's very hard to diagnose. Anyway, this is a fix. This is current fix. So know that subtransaction exists because I think no developers I know knew they exist. And there is no way to change the cache before PG17. Again, very good release. Not yet stable, but soon. And again, there is a conference in Vancouver that was about how it was changed in the PG17. Now you have I think the size is proportional to the shared buffer, and you have a bucket, so the lock is distributed between several buckets. But if you are not on PG-17 or you cannot switch, you're going to have to be aware of this issue. OK. Other case. Everything is crashed. So it's not fire-related. I realized when I put this background, but it could be. So when everything is completely crashed, you just think, most of the time, I'm OK with that. You just have to connect, see what goes wrong, and restart the process. It's kind of easy. Other cases, when you have to look for transaction stuck or whatnot, can be complicated. Usually, it's easy. So you just have to connect to the server. Or can you? OK, so no SSH. Doesn't answer to ping. That's the primary. There was a replica. Let's go to the replica. OK, that's different servers. OK, no answer. OK. We can still use IPME and see on the server what is actually happening. So let's go. Very clear. We can. I don't know about you, but I did not understand what was going on at this point. It's, I think, yeah. When you see that, it's a real output of the server this time. You say, OK. Maybe on the other server? No, same thing, of course. OK. So in IT, there is a solution to this kind of problem. A universal solution. We all used it. Exactly. Just restart it, reboot. Everything will work. Right? Maybe. So before I give you what happened next, I will tell you of the environment. So before NVMe, you know, the SSD drive, we had those kind of beasts. There was PCI SSD drives. So they are connected via PCI. They were the fastest SSD on the market. Cutting edge, really. Very expensive. And they did basically embark their own operating system. They were very smart about this, and they used proprietary drivers. And they worked fine. And this is what was used in this case. Also, both those servers were not too far away from each other, you see? So maybe something is related, and I will tell you why. It's because the network was too slow for replication. So they just put fiber optic cards in the servers and linked both of them directly for the replication. Why not? It was very fast replication. But after the reboot, it was not working better because we had this. And after 2 minutes, it did reboot. So it was rebooting in a loop for both servers. And there was basically nothing we could do. So at this time, I think it was several hours of downtime already, complete stop. And I began to look at other ways to solve the issue, like backups. Because in this case, you really want to backup. So you ask, do you have a backup? You're always afraid to ask this question. Yeah, afraid of the answer, exactly. So you don't want to have to ask this question. Now this, here I was surprised. Yeah. All right. All right. Great. Can we have access to the whole repository, for instance? Sure. OK, 3 days worth of walls. Perfect. Maybe we can restart production on another server. Can we have access to the PG bus backup or something, a file system copy? You know? Yeah, sure. I don't know about you, but usually I don't call PG bus backup a SQL file. But at this point, I was still hoping that it was just poorly named. But no, it was not, unfortunately. And why? Why in this way? And why? We'll give you one picture. Maybe we'll understand why. We all recognize it. It's our best friend, I guess, that is trying to masquerade as a Postgres. So yeah. Okay. There's always it's always a magical moment where you have to say to your customer that they don't have any point-in-time recovery at all. And then my customer actually said, OK, can we use the dump from the night before? That's a good idea, except your system crashed just before the dump. So you don't have the dump from last night, you have your dump from the day before. Do you want to restore and lose 1 day of production? That was no. But don't worry, it ended. It was an happy end. Because at this point, I did go back to the actual servers. And I did try my best so that it will stop to reboot in a loop. And actually, I found a way so that the system could take its time. And actually, it did check on its internal custom file system in the card, the specific card, and it did work, and everything was back. So, believe me, after that, they had the proper point-in-time recovery. So, key takeaway. It's amazing that it looks like I'm always telling the first sentence. Always test your backups. I've been saying this for at least 20 years, but it's always it's the most important thing. And if you can, don't put the primary on the replica. Don't use proprietary hardware if you can. It's not always possible. Life is better this way. Just use NVMe if you can. OK. If you didn't listen to me because I have a poor accent or anything, this is no, you can look, I have a bullet point, everything. So, summary. Collection are able. Yeah, but new one. The new one is fine. Oh, more collection. Yeah, one more standard, right? Yeah, collection can be able. We did a lot of tries, actually, because there was a collection linked to the OS, ICU collection also. I don't know about you, but I never saw ICU collection used in production. Maybe the only one. And now there is a C UTF-8, but C UTF-8, actually, I believe in it. It should be really good. So monitor connection, monitor Postgres configuration, swift transaction. You need to know that they exist. And again, PG-17. will add a custom, a way to customize the subtransaction cache. So very good. And again, backups must be tested. A backup that is not tested is not a backup. And that's it. Then, more generally, your Postgres issue may not be a Postgres. It can be something completely different. Because the last case, I show it to you on purpose. It's not Postgres' fault at all. So you need to do post-mortem, learn from them, and not fire the guy that did the mistake, because he has value now. And yeah, that's true. It's actually it's difficult because when I come at a customer, I'm like the firefighter, the hero, but people, they didn't mess up on purpose. It was not their fault. Most of the time, it's the organization that didn't give them the keys to answer correctly to the problem of the company. So master your stack, of course, but you need to be in a company that will help you do that. Expect the unexpected, because you can learn everything. You cannot learn everything, in fact. You will always, Postgres will always find a way to surprise you, and IT in general. And like I said, communication is very important between teams, especially in big companies where teams are in silo. If they don't speak between them, you will miss and lose some key information. OK? That's it? And if you have stories and you are OK to share them with me, I will be very interested.
OK, thank you very much. Nice stories. Are there any questions for these stories? Yeah, one question over there. Where's my other mic?
Hello? Yes. You mentioned... Now it's working. You had a mention about the threads in Postgres, but I think that you meant to say the processes, because Postgres is a multi-process program.
Yeah, sorry, I was talking about CPU threads, because I'm a sysadmin at first, so I'm always thinking of the usage of the system in terms of threads. But of course, yeah, you're right. It's process in Postgres. The project to, well, the discussion about threads in Postgres is still underway, and it's
going to be underway
for
a long time yet.
It's a big project that will take many years, and yeah, it's not here yet. You're right.
Okay, thank you for this clarification. Do we have one more question? Oh, far in the back.
I was intrigued about the, I think it was a 32 gig VM and an 8 meg shared buffers. And one of the reasons I was intrigued was because it's not actually the first time I've seen that. And I was like, how does it work? Because you would think it would be unstable, but it's not.
Yeah.
Is there any upside, like your master is no faster than your... It pushes to replicas. That's what I was thinking, because it was like... I didn't touch it. It wasn't, no one was crying, so I left it like that. But it was like, you know, it was a very similar configuration, 8 meg for the shared buffers, and it was a big VM.
I can tell you that replication was working fine during this issue. No problem. Some queries were failing, actually. I think some queries needed more than 8 megabytes. But other than that, it was slow. But it did work. That's still amazing for me. Yes?
So, sorry, just to clarify, I was not aware of anything failing. I heard that there were some performance problems, but It wasn't enough that actually anyone wanted to change anything. So did you say queries were failing as well as being slow? We did have slow
were
queries.
failing, yeah. Sorry, it was some years back, but I think some big queries didn't work at all. And I need to double check that. But yeah. Oh yeah, you're right. There should be. There was a statement timeout.
It never fails. And definitely Postgres is remarkably resilient.
yeah. So that may be the statement timeout that did kill them.
But like it never finished.
Yeah.
Okay, last question. No final questions? All right, then we break and we continue at 15 minutes past 3 o'clock. And there is a sponsor raffle at sponsor EDB. I think they're having some prize for if they scanned your badge. So if they scanned your badge, please check out. If you're not there at the raffle, then you can't win anything. And once more, one round of applause for Jérémie. Thank you very much.